So we need to talk about 2.1.2. It's how can we shift a parabola. So we're going to look at some parabolas and some shifting. So if we follow problem 11 in our fancy textbook, they have a little parabola lab for us to work on together. So ultimately, you guys know what a parabola looks like? What shape we kind of call it? It's from a quadratic function. You get like the little U shapes.
I know what it is.
And sometimes they're shaped more like this, one way or the other, right? So we're going to look at some parabola, some quadratics, and see if there's any patterns that we can come up with when it comes to shifting these. So shifting it to the left, shifting it to the right, up, down, upside down, those types of shifts. So they want us to start by graphing y equals x minus 2 times x minus 2. So we can go to Desmos. We have what? X minus 2 times x minus 2. And it gives us our U-shaped parabola, right? Our little quadratic. So there's a couple things when it comes to our quadratics and our parabolas that we need to know. So I kind of cheated a little. And I just put it on here so I can write on top of it. So the one thing we need to always be able to know is what's called our vertex. Have you guys learned about vertex before?
Vertex is like this spot.
Yep. So it's this spot down here, right? So when it comes to the vertex is what we refer to as like a turning point. So if you think of like your graph, reading it like a book from left to right, if I start here, like I'm going down, right, my values are getting less and less and less and less and less until I get to the vertex. And then once I get to the vertex, my values start to go back up, right? So your vertex is also called like a turning point because it's where your graph, if it's decreasing, it's going to start increasing. Or if it's upside down, it'd be increasing and then it hits that vertex and then it starts to decrease. We label vertex. I need to get a different color here. Our vertex is a point, right? Points are x and y coordinates. So this is our vertex. What's my x value at that point?
I can't read the numbers.
Yeah, my little green dot went over it, and it's 2. And then my y value is 0. Okay? So we need to be able to label our vertex. The other thing we need to come up with is our line of symmetry. And what's symmetry mean?
Symmetrical, the same.
Yep.
So like where do you flip it over and be the same?
Yep, absolutely, right? So there's all parabolas will have that line of symmetry where it's going to be the same on one side as it is the other. And it's really pretty much like right down the middle where the vertex is. So our line of symmetry goes right through here, right? So we need to be able to name our line of symmetry. So horizontal and vertical lines, it's either going to be x equals or y equals. Did you have something to say? Okay. So we need to figure out if this is going to be a y equals 2 or an x equals 2 line. It's going to be x equals 2, right?
Here's the x-axis, right?
Yep. Yep. Yeah. Yep. Good job.
Because if here's the x-axis, like it runs up and down the x like that.
Well, the y-axis.
So
And
the
here's the
y
y.
symmetry, if like our parabola was this way, it'd be the y.
Right. Here. So that line of symmetry, it's got to be the same. So if you look at this graph, like on here, right? If you folded it over that line, you would get the mirror picture of it over here. Okay. So we're flipping it or reflecting it over that line. That line would be when x equals 2. Yep. So now they want us to start with this little equation that we had, that x minus 2 times x minus 2. But they want us to play around with the numbers and see if we can, it says, use your graphing calculator to find the equation of two parabolas with different graphs that also open upward and have a vertex of 2, 0. So we want it to look like this, shape-wise, right? It's opening up, our ends are going up, and our vertex is at 2, 0. So we're gonna flop back over to our Desmos. Oh, it went away. And we had x minus 2, x minus 2, right? So we want it to have that same general shape, and we want it to still go through the same vertex. So since we're doing this all together, where would you guys like me, what would you like me to change?
You want it to have the same vertex? Would you change the x?
Here, let's, whoops. We'll keep the original one up there. All right. So what do we want to do? Sorry.
Would you change the x?
What do you want to change the x to?
I don't know. The first x or the second?
All right, first x, second x.
I don't know.
Well, we just got it right.
Change the first x to 1. This is even moving.
Well, like change the x to a1 or put a 1 in front of it?
Change the x to a1.
Oh, come on. Oh, there it is. That made a line, right? Because now, let's think about that. It made it a line because if we look at our x, right, if we have that 1 minus 2 times x minus 2, yeah, well, it's a number, but our exponent on the x is going to be 1, right?
Oh, so it's the same.
So it's going to be a line. Yep.
So we have to change both of them?
Change both of them?
Yeah.
What do we want to change them to?
Try to.
You want a 2 on this one or a 1? A 2. What do you want to change this one to? Negative 2? So you just created a number. So when it comes to our functions, like our x is our input, right? And our inputs can hopefully, for the most part, be any value. So we really kind of want to keep our x's. We can add to the x's, but we pretty much want to leave the x's there.
So it's the numbers. Could you change both of the numbers? Or would you change? Oh, wait. If you're trying to make the opposite, would you just change the positives to negatives, like negatives to positives?
So what do we want to do? X plus 2?
And then change it.
Oh. So the shape looks the same, right? But we moved our vertex.
How do we get this shit?
All right, so let's go back to our... What else could we change? Say again? Minus x? Well, 2 minus x is the same thing as negative x plus 2. Do you want your... If you have x minus 2, negative 2 plus x, that's the same thing. It's just in a different order.
Yeah. You'll end up
Right.
with the same number. What if you just... Holly, could we do the... What's the formula? It's like y1 minus y.
Oh, why did... No. I don't like the fact that this goes away every time. Alright. So far we've kind of picked up that if we move, or if we change that negative 2 to something, that just like shifted it left and right. So we don't want to shift it left or right. We wanted to leave it where it was. So we're leaving the negative 2's, right? Because if we made that a positive 2, it shifted it. Yeah. Do you want the negative on the outside or the inside? Outside?
Yeah.
Back here? And put a negative out there?
Hey, I got half of that.
Yeah. So what does the negative do?
Makes it...
It flipped.
It makes it flip, right? Now, on the question, did we want it to flip? We didn't want it to flip, right? We wanted it to stay the same. We ultimately wanted to make it like skinnier or wider, right? So granted, we know that that negative is going to flip it, which is a huge, huge thing. So, but we know we don't want it negative because we want it to go in the same direction. So we're going to keep the negative out of there. Anybody got any other ideas?
An exponent. Now that doesn't make sense.
Yep, right, because if we add more exponents, then that completely changes the family, right? How many x's are like right there? Like in that first one, that x minus 2? There's technically 1. Could we change the number of x's? Like put a number out front?
Put a 2 in front of x.
In front of x right there?
Yeah. Well, she was saying to change the amount of x's.
Ah, so close, right?
So add an x to the minus 2, minus 2x.
What if we put a number out front? 2?
Negative. I got 1.
Well, what did the negative do?
It flipped it. Oh, so negative 2.
But do we want it flipped?
Positive 2.
Positive
I'm
2.
not gonna lie, I don't know what we're aiming for here. What are we looking for?
We're supposed to leave. Yep. So you want it at the same vertex, but you wanted to change the graph to either make it skinnier or thicker. Yeah. Did we accomplish that?
Like this flip to like the different quadrants. My bad.
But then your vertex would change if you flipped quadrants, right? We wanted our vertex to stay the same. Yeah.
Oh,
Yeah.
that's why I think I thought you wanted it.
Yep. So did our vertex stay the same?
Yeah.
Yep. Yeah. So what did
The 2 in front just made it bigger.
did it? No, made it smaller. Yep. When we put our numbers out front, can you guys stop, please? If you guys want to have your side conversations, just go out in the hallway and have your side conversations. When we put that number out front, because you're multiplying it by 4, right? If I take anything and I multiply it by 4, right? Right. So when we put that number out front, you multiplied it by 4, so ultimately it's going to get there 4 times as fast, right? If you take anything and you multiply it by 4, you're getting there faster. So when it comes to our values, when we're looking inside of our graph, wherever that 1 is, instead of getting there like the 0.12, you're getting there like 2 times or 4 times as fast. So at 1, it's going to be like at 4 or 8, depending on the function. So if you have a number out front, you're going to get there faster. So we say that it like stretches the graph, makes it get there faster, so it makes it skinnier. Pardon me?
How would you make it bigger?
Oh, I don't know. What do you think? How would we make it bigger?
The second. Would you put it up right in front of the second one, or would you put it at the very end?
So if that 4, right, makes it get there faster, so we got to figure out a way to get something smaller. So if that's a whole number greater than 1, we know it can't be negative because negative is going to flip it. What if we made that a fraction? Let's try 1/2. Can I just do 0.5 for a half? And what did it do? It made it bigger, right? Because now, instead of getting there like 4 times as fast, you're only growing as half as much. So if I normally would have grown this much, right, by a 1, I'm only growing by half, so I'm only going here. So it's going to take me twice as long in order to get there. So it's going to make my parabola go out farther because it's going to take twice as long for me to get out to where I need to be. All right. So let's write some little notage on that. So we had y equals x minus 2 times x minus 2. Right? So let's kind of write down some of the things that we tried and what it ended up doing. So here. Yeah, we're going to draw some cheesy little graphs, right? 1, 2. So that was the parent graph, or that original graph, right? And I'm going to change some colors. So the first thing we did is we ended up making those y equals, we changed the sign, didn't we? We said x plus 2, x plus 2. Anybody remember what happened when we did that? Yep, it was over here, right? So if we change the value inside the parentheses, we're able to shift things left and right. Okay. And then, oh, we threw a negative out front, didn't we? Y equals negative x minus 2, x minus 2. And what did that negative out front do? It flipped it. So it kind of looked like this, right? So if we change the values inside the parentheses, it moves it left or right. If we put the negative out front, it flips it. And then we put a number out front, didn't we? We did like a 4, x minus 2, x minus 2. And what'd the 4 do? It made it skinny, right? Because you got there 4 times as fast. And then we threw out a half. What does the negative do? The negative will always flip it over the axes, the x-axis. Mm-hmm. And I think it went yeah. No, you're all right. You're all right. All right. And then when I did the half, it made it wider, didn't it? They almost look like the same color. Can you guys tell that's pink? Yeah. Right? All right. So when it comes, yes. Yes. So when it comes to parabolas, in Algebra 2, we spend a lot of time on functions, and we spend a lot of time on shifting functions. And the great part about this is like we learn how it works when it comes to parabolas and these quadratics, but that same format follows for any kind of function that you're looking at. If you think of a line, if your line is, like positive, right, it looks like this. But then what happens when you make it negative? It actually flips over, right? So even on a linear, whatever you're doing to a linear function, all of those still apply. When we get to cubics or exponentials, we can sit there and figure out the pattern on how to change everything. So it's kind of an important piece that we know how to transform our functions.